August 30th. All right, let's do this. Minimum what? Minimum replacement to sort array. Given a zero-indexed integer array, in one operation you can replace any element with any two elements that sum to it. For example, considering nums, in one operation you can replace num1 with 2 and 4 and convert nums to this. Return the minimal number of operations to make an array that is sorted in non-decreasing order. So in one operation you can replace any element with any two elements that sum to it. So in here I can take this, I can take this, 2 steps. Holy crap. How are we gonna do this? Minimum replacement. One replacement. I mean, if you replace a value into two values, and one is small, one is big, and then you say after the replacement, we will make it better, then I can always say you can replace it into two values that's exactly the same, right? Well, that's actually not true, because in this one, if you replace this with 4 and 5, then it's not gonna work. I want a minimal number of operations. But I mean, can we do it without considering minimum operation, just the number of operations? Like, didn't really care, just give me some operations. 1 or 2 or 3, it doesn't matter. I mean, we can always do a lot of operations, right? Everybody can turn back to 1 and it will always work. But we want a minimum operations. This kind of feel like, you know, you're thinking we can DP it? Can we DP this thing? And I was thinking about binary search. You know, we have certain amount, certain number. If we binary search, we say I want certain number of operations, and we just need to see if it's possible to convert it into a sorted array. But how do we know it's possible? I mean, we can not sorted. Well, yeah, it's basically sorted it. But we need to know which ones to change, right? Which ones to change. Now we don't know which ones to change. We don't know. I think binary search might not be the right way to go. I mean, if it has to be non-decreasing order, right? Which means we shall always try to, if we go from right to left, okay? Because when you split them up, it's always going to get smaller and smaller. So if we go right to left, the rightmost one you definitely do not split. Because if you split and it will still work, right, then you don't split will always work. So the rightmost you almost always don't split. No, you just don't split the rightmost. So that's your ceiling, right? That's your ceiling. And then, because the rightmost is your ceiling, right? So everything has to be smaller than the rightmost, or smaller or equal to. So if you have someone that's bigger than the rightmost, and in fact, if you get something that's smaller than anything that's, so from right to left, anything that's smaller becomes the new ceiling, right? It becomes the new ceiling. Okay, so we have the rightmost, let's say a certain value, and then you look for the second to the right. Okay, if it's smaller, then that becomes, and you don't want to split, because if you split, you simply make it even worse, right? So you will split a value if it's bigger, and this way you split is to split exactly the same as the current largest one. You split this one out, and then you have a remaining. And if this remaining is still bigger, then we just keep splitting until it becomes a smaller one, and that becomes a new new limit. Now, if we are talking about this, right? If we're talking about this, then it's basically greedy, right? We go from right to left. Yeah, I think it makes sense, because the rightmost you can definitely not split. Because if you split, just make the situation worse, which means we can probably just go ahead and solve it like this. You know, we'll solve it like this. Nums, right? So we go right to left, and we need to know the number of times. So we can say int now long, and then for int I equal to nums dot length -1. No, actually -2. I large equal to 0. I minus minus. And we have the int lim. Right? And then we say if nums I is larger than if it's smaller or equal to lim, then we don't do anything. We simply say lim equal to nums I. We reset this. Else, if it's larger than, then we need to know how many we can take. Right, so we just take one, take one, take one, take one. So we say in the queue, rest plus equal to nums, because you do a split, right, divided by 3. If this divided by 3 is going to be 3. No, 3 times 3 is 9. So we take one, but we don't take another one. So basically what we're saying is we will remove one. Depending on the remainder. So every time you have the remainder, if the remainder is 0, then we borrow one, all right? So we'll get the remainder shall equal to nums I mod limit if r is equal to 0, how about this? Rest plus equal to nums I divided by lim, right? And then if this, then rest minus minus, and lim equal to we don't change lim, else so limit becomes r. Then we keep going again, keep going again, keep going again. And then we'll return Alright, what do you think? This, greedy approach. Nope. It's almost correct, but not 100%. Can we have a easy thing that's going to run out? This is right. Okay, we know this one is wrong, so how about we do something like this? I just need to find. Okay, that's a good one. Probably can remove this, doesn't really matter. All right. Okay, I probably can make them smaller. Yep. Probably can make them maybe even smaller. That I'm not sure, but we can try. This one work? Ugh. Okay, that's good. All right, let's try this. Let's see how we are supposed to get this to work. Oh, I mean, in this case, probably I don't need this, right? I can remove this. I think it'll still work. Yep, 65, 3, 5, 7, 54, and 3. So in my mind, I have these 3. And then 54 divided by 3. Right, 54 divided by 3 is 18. So basically we have remaining 3, and we to take 17. So 17 times 3 plus 3 is 54. And the 7, so we take 2, right? 7 will be 4, 3, 4, 3, that's 1. And then 4 will be 1, so that's 2. So remaining is 1. And if it's 1, that's what take 4 away. Right, I take 2 away, I take 4 away. So the answer will be 4 plus 2 plus 4 plus 2 plus 17. Oh, that's 65. It'll be 64. 89, that's my output, but it should be 87. how do you figure 87? Oh, holy oh, I see. It goes 3, 3, 17. And this don't go 1. You get to 3, 4. Right? And you divide. That become 2. So you basically do 2, but that become 2. Oh, that's the trick. So when do we need to do this? Well, the whole point is the current value is bigger than the limit, right? So you can split. Because the whole point is, if you don't split. Now the reason we take away the limit is because if you take it away, the remainder is still going to be bigger, right? So you keep taking it away until you hit a point where you have a remainder, right? You have a remainder. So you have a Q and R, that's a div mod, right? Which is your num I and your limit, right? And R is going to be smaller than limit. And we can have this, but we try to make it as big as possible. So what we can do is, well, R will be plus a limit, right? We got a new value, and Q, and then we minus 1. And this we'll try to see if we can split in half, right? If we split in half or really close to each other, then we might get a value that, because it's going to be a smaller one, right? It's going to be a small plus a, so R is going to be a small. So R is smaller than lim. So R plus a lim was smaller than 2 times lim, right? It was smaller than 2 times lim. And which means we'll divide 2, it will be smaller than the limit. So, and this might be bigger than the R. It's actually most likely it's the worst case is R equals lim minus 1, right? If R equals lim minus 1, then we will take R, right? We still do R plus lim and divided by 2. That will be the thing. If in the other case, then we'll get something that's bigger than R, right? As the whole point is to get a bigger than R, because this is smaller than lim, so we can move some from lim to this, and we can make it a little bit bigger. So with that in mind, we're gonna make a little bit change. R is this, right? What if R is equal to 0? Yes, R is equal to 0. So we don't really care too much, right? So we get an R. If R is 0, we do this, limit doesn't change. Otherwise, this needs to change, right? This needs to change. Basically, what we're saying is the last one is going to be R plus lim, right? R plus lim divided by 2. That's the smaller one, smaller half. So what we're going to say is, do not use R as the next lim. Instead, split R plus lim to get a larger value. So with this simple change, we might get it right in this one. Yep. Think that's the case. Yep. So we can say it's, you know, it's greedy. From right to left, the rightmost must not split, because otherwise we will always be left with a smaller value to handle the remaining numbers. Thus, for each number, we let's set the limit to the rightmost value. For each number, we try to take as many limit away from the current value, from the current number, if the current number is bigger, right, than the limit. But pay attention, we don't take all of the limit. We leave one and then split the remaining, split the remaining to get the largest possible value that is smaller or equal to limit. No, I think it's just smaller than limit. This is the trick that I didn't get in the first try. Okay. All right, let's see. Oh, it doesn't work. I was so confident that it will work, but it does not. All right, we have to work a little bit more. Let's see. I thought that was it. I kind of see how it's gonna be. It's like if I split this, then we need. I see. If I think about this, in fact, maybe I can just do this. This one's accurate. I don't know. Give me something. Give me some. Is this one enough? Yep. Yeah, I think that's a good one. Can even try this. I think this one will also be wrong. Ah, shoot. Let me throw away these. Ah, shoot. This won't work. Okay, this won't work. I think I can try this one. Okay, let's try. 256, 346, 22, 277, 179, 223. Yeah, so the way I would do 179, right? So 179, then we have 277. Yeah, so I basically do 277 divided by 2. I got 138. That's the first one. Now I have 22. So I'll take 22. And then $346. Now start take 22 away. 346 divided by 22. 15. So 16. So I'll say I'll take 14. Right? No. Still 15. Because the last one still have to split. So take 15. Then we have 16 plus 22. Then it will become 19. Right? 256 divided by 19. 13. 13. So I have 13. That's 29. Yeah. And then so 9 plus 19. So I end with 14. Okay. This is my result. How could you make it better? Well, 179, you're telling me that that's actually quite interesting, because I'm pretty sure this shouldn't be a big issue, which means if I delete this, is this still wrong? Yeah, that was the issue. 27, I got 28. Yep. So we only need to consider this. 256, 346, 22. If we use 22, that should be 28, but I don't know. What you saying? That we can I really have no clue. How'd you get 27? For 22, 14 times, and plus 19, right? No, plus, wait, hold on. 346 divided by 22 is 15, right? 15 times 22 minus 346, right? 16 plus 22 divided by 2 is 19, yeah. So we take 22, we split it 15 times, 14 times, right? We split 14 times, then we have a 38 left. So if we do 14 times, then we have a 38 left. Now you're telling me that I might be able to get a 22 and a 16, which gave me 15 here. And then 16, I can do 256 divided by 16. I can have 16 here, but I don't have 15. But that's 30, right? Doesn't make any sense. The biggest is 19 and 19. That's the biggest. Huh? Okay. That's fine. Let's just take a look at this. Is this 15? Yes, it's 15. Let's also try 256, 19. Two 56, 16. I think these are only two possibilities. It's a 13. Right? It's a 13 and it's a 15. Which, this is a 15, this is 13, that's correct. It's a 28. So, based on this, we can kind of tell things are slightly different than what we had expected. It's 27. Very interesting. Why is 27? Which means it's not 19. Right? $20. One, 22. Let's just see. $27, $27, $27. Last one, $39. Okay, the middle is all 27. So this, these are all 27. Okay, that's what we need to work on. Yep. 256, 20, 346, 22. 20. How the hell is 20 gonna work? It's 12. So 20, right? This will be 12, and this will be 15. So that's give you the 20, 27, right? But 20, which means this at the end give me a 20. Are you kidding me? I guess not. 346 divided by 15 is 23. Hold on. If we do 20, holy crap, I think I know. So if we take 22 every single time, right? We take 22, 22, 22. So we take 14, 22, another 22, and then 16, right? Now what I'm saying is we don't do that, okay? We can make this 17, 21, right? 18, 20. But we can also make this 20, and this is 20, right? We're going to do 20, 20, 20. Of course, we want it to be 22, right? We want it to be 22, so we get, so, okay, how about this? So it has 16, and now we have 22, 22, to 22. I have 15 of them, right? I have 15 of them. Now we want this to be 22, but it's not possible because we're 6 short, right? We're 6 short. But what we can do is we can move a value to this, move a value to this. We can move it to 21. If you think about it. Now this require, oh, we can move it to 22. No, we cannot. I mean, that's fine. Like, we're 6 away, right? We're 6 away, so we need to plus 6 to become 22. So I can plus 6, which means 6 of them need to borrow 1 to this. So now I become 22, and these are 21. We have 6 of them, and then we have 22. Now we have 9 of them. So it should be 21. That's a very interesting way of thinking. I never thought about this. Well, we know it's not going to be 22, so we shall ask is it possible, right, to become, what's the maximum it can become, right? So basically, the maximum, so we cannot become this value, but we have that many this. So the worst case, we can remove 1 from each of them, put in here, and see what this value gets. That is a very interesting idea. Very interesting idea. Because, yeah, if we have a limit, right, and we know we cannot get limit, so the maximum we can get is limit minus 1. So now you want to see if limit minus 1 is possible, right? And how to make this possible, we take everything away, put in here, so we make this as big as possible. And if this is smaller, okay, so okay, let's try a new one. Pay attention. This is where the trick comes into play. The remainder, right? After taking as many limit away, we are left with the remainder. Now in this case, in this situation, if the remainder is not 0, right? If the remainder is not 0, then the max limit we can pass on to the next number is limit minus 1. Thus, we want to borrow, okay, 1 from each limit in the quotient and add it to the remainder, right? If the new value is bigger than limit minus 1, then the next limit is limit minus 1, right? Otherwise, it is the new value, which is remainder plus quotient. That's yes. So we'll do this in Q equals to nums_i divided by lim, right? So rest will plus equal to Q. No question about this. If this, otherwise, lim shall equal to R plus Q. R plus Q. Is this larger than limit minus 1? Right? If it's larger, then it can be limit minus 1. If it's smaller or equal to, then it's R plus Q. That's that. Oh, what happened? Can be replaced with math. Min call. Yeah. Good one. Math min. Okay. Okay, we got a 27 right, but the last one's still not right. Oh, it's rough. What else? What else do we not consider? Make sure that all the other ones are correct. 2 0 2 0. Yeah. Huh. I don't understand. Fact. A little bit frustration right at the moment. Thought I got everything right. I don't need this. Probably can remove this. Okay, that was good. Probably I don't need this. That's good. Maybe I don't need this. Ugh. That was critical. How about this? Ugh. So these are... So maybe I don't need this. Yeah, usually the first one I think I can remove because the first one doesn't really matter. Oh my god. Everything matters. You gotta be kidding me. Can't even remove even a one value to simplify the test case. Seriously, cannot remove even a single value to simplify the test case. Alright, let's give this test case a shot. We have 328, 242, 260, 346, and 22. Alright. Our analysis 346 divided by 22, so we have 15. Okay. We have 15. Okay, so 346 minus 22 times 15. We're left with 16, right? So it'll be 16 plus 22 times 15. So if I add 15 to this, so this one should be 21, right? Limit becomes 21. So we do 260 divided by 21, get 12. And 260 minus 12 times 21, we're left with 8. 8 plus 12 times 21. Right, again, I have 12. So it'll be 20. Because I cannot be 21. So it has to be 20. So now 242 divided by 20. We got 12. So 242, 12 times 20. So I have 2 left. Okay. So I put 12. So this one gave me 14. And last one, 328 divided by 14. Doesn't matter, this one will give me 23. So here's my answer, 23 plus 12 plus 12 plus 15. 62, expected 57, okay. And we have tested that this is accurate, right? 39 is accurate, which means the last one instead of 23, I shall only get 18. 18. What in the world? So I'm doing 14, right? That's what I do. And I always do 15, 16, 17, 18, 19, 20, 21, cannot be larger than 22. Okay. No way. That was bonkers. Look at the last one. Look at the last one. We set it 22. The last one. Expected is 49. What in the world? How is that even possible? Like, seriously, this is probably the most outrageous. Right? This is probably the most outrageous. You can split however you want. How in the world we get a 49? Basically, that's 39. This is 39. And you said 49. How? Oh. Wait a second. That's not what I had in mind. Ugh. It's not what I had in mind, but it's a good practice, right? It's a good practice. Like this one, I got it wrong too. So it's a different one from this, but we got it wrong too. 242, 22, 260, 346, and 22. We know these are correct. 12, 15. Right? This one we get 21. This one we get 20. And this, I would do 1. So remaining 2. So 2 plus 22. So I put 1, so that will become 3. That's not right. That ain't right. So when this is really small, oh, I see. When this is really small, I need to keep sacrificing. I sacrifice 1. This becomes 3 plus 21. And I keep sacrifice until these two are only 1 apart. Right? Not really until these two are 1 apart. Just we have to find the middle ground. How do we compute it? I mean, limit is 20, actually. Limit is 20, right? Limit is 20. So 20 plus 2. So I want to take some to put in here, right? Such that this one can go up, these go down. Until a point where, so I can do another one, do another one, do another one until, because each time I can get something out, right? And add it to this. So each time I can quick quotient out. So times how many quotient, and I have the remaining plus this. And this would just be your limit minus this. So we'll do this, right, until a time when this is bigger than it, right? So we can know what this Q is, what this thing is going to be. Right, in this case, 2 plus how many times should larger than 20 minus this. So 2 this might larger than 18. Right, larger than 9. Now we can do larger equal to. So we take 9 away. So if we take 9 away, this will be 11, this will be 11, so they will be equal, right? So if I take that away, and this becomes larger than this, right? This becomes larger than this, which means if I put this one back, this will be small. This will be small, and this will be 1 bigger, right? So we'll take this. But if we come all the way here, then this will be big, this will be small. So we're going to put this back, so it should be this value. So we find the maximum we can get, right? So we want this to be larger, equal to this. So we take, if it's equal to, right? If it's equal to, then we just take that many. If it's larger than, then we don't use this, we use this. It's going to be this value. So in this case, it can be 11. Right, so this is still, we split once. Then we rearrange. Now if it's 11, then 242 divided by 11 is 22. So we have 22 here. So it's 22 plus 1 plus 12 plus 15. That's 50. Oh, because 242 divisible, so there's actually 21. So that's 49. Oh. Okay, so let's make further changes. Okay, for each number, we divide it by the limit. If it is divisible, we split it by lim and get q as quotient and r as remainder. If it's divisible, the next limit remains the same, and we perform q minus 1 splits. Otherwise, we perform q splits, but we want the next limit to be as big as possible. To do so, we need to increase r by taking one value from each limit, each of the q limit. We keep doing this until r becomes bigger than the value after once having been taken away from the limit. Right? Then the next limit is the remaining limit after such operation. The purpose of doing this is to ensure that right? This is to ensure that the next limit can be as big as possible. All right, so with this in mind, we'll still do this. This is still right. This is not right. Okay? So what we need to do is to find out what the number of times it's going to be. Like say, suppose we need to do the taking away k times, right? Then we want r plus k to be larger or equal to r plus k larger or equal to q, no, limit minus k, which is k should be larger or equal to limit minus r divided by 2, right? If it's doesn't matter, so we have the k, we have this value, right? So if it cannot be divisible, if it's not divisible, right? If it's not divisible, that means we need to take this so maybe we can say int k shall equal to math.floor. No, I think ceiling, right? Oh, it's fine. Lim minus r 2.0. This one work? It's a double. Wait, what? The ceiling does not return. Wait, what the hell? All right, maybe we have to do ceiling div. All right, ceiling div int Java ceiling div. I just want examples. So it's just a ceiling, double it, and it become an integer. Oh, this is just source code. I don't want source code. I want to. Return the smallest long value. No, int. That is greater than or equal to the algebraic quotient. Yeah, I think that is the one we want, which is limit minus r and 2. Lim. I don't have a limit. So lim. Right? So that is, and then what we're going to get is going to be limit minus this. Okay, divided by 2. No, that's q times, my bad. So this shall be q plus 1. Just this, q plus 1. Q plus 1. That's the, do the maximum of this. Oh, wait, do the maximum of this. Then we will add, now add a k. It should be minus equal to k. Or we can just minus equal to this thing. Alright, I'm going to take this. If it's divisible, fine. You know what? I want to double check this. J shell, right? Math.ceiling div, let's say 6 divided by 2. That's 3, right? If we say 7, it should be 4. That's how I imagined. So I do that, right? Limit into minus equal to this, because it has to be 1 more. Right? If k is not an int, we take the ceiling off it. All right. Try one more time. Cannot find symbol. You gotta be kidding me. It's at, wait, which Java are you running on? Seriously. CO diff. Oh. So I can't even use it. That's fine. We can do seal. Double of this. And then we'll int this thing. Because I saw the implementation. So okay. So that one works. You know what? We're just gonna, we run the whole thing. these whole shenanigans, they are correct, right? We keep adding. Actually, I just add this. All right, I think this one's right. So, it's not really that hard. Actually, it is pretty hard, but I think I just didn't pay too much attention on how to form this thing. Yeah, it does require some thinking. We know it's greedy, right? We know it's from right to left. So the only thing that's troublesome is when how to make it as big as possible, right? When you know the maximum value you can split into, how to divide the whole thing such that we can get the maximum possible. Well, the way to do it is you take away as many as you can, you have a remainder, and you try to add it back, add it back, add it back, right? So many times you add it back until this is larger than everybody else that you know that you have found. Yeah. Good question. Yes. Yeah, it is seeding division, right? That's a good way to say evenly distribute. Yes. All right, that will be it. I mean, not really we did go through a lot of trial and error, so definitely not the best, but I think it's a valid effort, right? It's a valid effort. All right, so I'll end it right now. I'll see you guys later.